Yes, yesterday's class. Yesterday's class, just introduction given, basics are discussed, like software basics. Yes, what is software, system software, what is application software? Yes, what is OS, about OS. Next, is front end, back end, language packages. Yes, language. So languages, low level language, high level language. Yeah, this topic we should discuss. Let us start. Java is a language. Java is language. So starting with languages. Okay. See here, the way introducing the Java started from basics, software basics. Software basically two categories: system software, next application software. Java is a application software. Java is an application software. So that is the reason moved to application software. Yes, application software, again two categories. Java comes under front end. So move to front end. In front end, language and packages. Java comes on languages. So let us move to language. Yes, let us start with language. Of course, yesterday some introduction given about languages. Yes, we'll start. Start with language. Okay. Yes. Yes, language. Yes, what is a language? Yes, language just it's a media of communication. Just it's a media of communication between two living things. Just it's a media of communication. Language is a media of communication between two living things. Maybe two persons or two animals or two trees. Okay. Just media of communication. Yes. Come to software here. Yes, in software, see computer understanding some language. Computer understanding. Yes, computer understanding some language, right? Some language. Next, we are understanding a different language, right? We are understanding some different language, right? Yes. What is computer understandable language? Computer understandable language. Computer understandable language. So what is computer understandable? Means system understandable. Computer understandable. Yes, what is computer understandable language? Computer understandable language. What is computer understandable language? Computer understandable language. Yes, it is. One second, let me mute all. Yes, what is computer understandable language? Yes, it is a binary code. It's a binary code. It's a binary code. See, binary code, yes, in zeros ones format, zeros ones format. Binary code. Yes, here computer means what? It's a processor understandable language. Processor. It's a processor understandable language. Yes, it's a processor understandable language, right? It's a processor understandable language. Processor. Now we are using processor based computer. See, there are different generation of computers. Yesterday we discussed about the different generation of computers. Yesterday we discussed about different generations. Okay. Yes, generation of computers. See this. Generation of computers. Yes, first generation. Yes, vacuum tube based. Second generation, transistor based. Third generation, IC based, integrated circuits. Yes, fourth generation, microprocessor based. Okay, next one more row. One second. See, fifth generation. So next coming AI based. Now it's a processor based computer. It's a processor based. Now we are using processor based computer. So next generation is fifth generation AI based artificial intelligence. Now we are using processor based computer. Yes, it's understandable language, zeros ones for binary formats. Okay, it's a binary format. It's in the form of binary code here. Binary code. It's a system understandable language. System understandable language. Okay. Yes. So this is, yes, it is a system understandable language. System understandable language. System understandable language. Yes, system understandable language. Understandable. Okay, system understandable language here. System understandable language. It's a system understandable language. Okay. Yes, it's a processor understandable language. Right. Okay. Next, we are understanding some different language, right? That means user understandable language. So next one is user. We are the users of computer, right? Yes, user understandable. User understandable. User understandable language. So what is user understandable language? English. User understandable language. Simply it's English, right? It is English. Just it's English. It's English. Just it's English, right? See, all the programming in English language on here, like C language, Java, or C++, all programs like English language. English language. So user understandable language called as high level language. Computer understandable language called as low level language. Okay. Yes, in software, language are two categories. First one, yes, low level. First one, low level languages. First one, low level languages. First one, low level languages. Second one, high level. Second one, high level languages. High level languages. Okay, low level, high level languages. Okay, there are two categories of languages in software. In software, two categories. Low level languages. Low level language. So what is low level language? Low level language. Yes, it is a system understandable language. System understandable. System understandable. System understandable. Okay, it's system understandable language. System understandable language, right? Yes. It is in the form of binary code. Yes, it is in the form of, binary code. It is in the form of binary code. Binary code is like zero response format. Binary code. Binary code. See here. Yes, how that binary code is, what is binary code, how it's working, we'll discuss next. Next coming topic, we'll discuss. Okay, it is in the form of binary code. Okay, right? Yes, it is called as machine language. Yes, it is. It is called as machine language. It's called as machine language. It is called as machine language, right? It's called as machine language. Okay. Yes, low level languages. Yes, it's a system understandable language. It is in the form of binary code. Yes, it is called as machine language. Here, system means it's a processor. System means processor. System means system. System means, yes, it's a processor. It's a processor. It's a processor. So what's a current processor we are using here? 8086 processors we are using. Previously 8085. Old processors. In 90s 8085. 90s 8085. Now we are using 8086 processors. It's a processor understandable language. So this is low level language. Low level language. Okay. Next, high level language. High level language. Yeah, this is user understandable language. High level language. User, yes, understandable. User understandable. User understandable language. User understandable language. It's a user understandable language. It's a user understandable language. High level language. It's a user understandable language. It's a user understandable language. One second. One second. Someone is struggling to join. Just a minute. Yes. User understandable language. High level language. User understandable language. It is like English language. It is like English language. It is like a, yes, English. It's like English language. Like English language. Okay. Yes. Fine. Yes, like C language. C is a first high level language. C is a first high level language. Later, all the high level languages like Java, C++, all the high level languages. These are like English language, right? Yes. One second. Suppose let us take some Java program. Suppose Java program. Java program. Simple program, very simple program, some tested Java program. See, this is like English language, right? A system cannot understand this. System cannot understand this language. Okay, suppose let us take C language. One more example, C language. C language. C language. Suppose this is some C language. Yes, C program, right? C program. Yes, these all are like English language. All are like English language. Suppose Python. Let us take Python example here. Python. Yes, Python. Yes, Python scripting. These are like English language. All are high level language. These are high level language. Yes, very easy to understand. But system cannot understand. System can't understand this language. Okay, system can't understand here. Yes, someone has to convert all the high level languages to machine language. Who will convert this? High level languages to binary codes. High level languages to yes, system understandable language. High level language to binary codes. Binary codes. Yes, who will convert this? Someone has to convert. Yes, someone has to convert from high level language to binary code. Who will convert? Who will convert for this? Yes, either interpreter. Yes, either interpreter or compiler. Either interpreter or compiler. Compiler. Yes, converts. Converts. Converts from yes, converts from high level language to binary codes. Binary codes. Once it converted to binary codes, then executes. So finally generating outputs. That's it. Yes. After this yesterday we discussed. After this branch. Now let us see what is interpreter and compiler. Yes, what is interpreter and compiler? Okay. Yes. So once you understand this interpreter and compiler, you can understand about Java features. Yes, about Java features. Okay, to understand Java features, you must have this knowledge, basics about OS knowledge, about interpreter compiler, about exe file. If you have that knowledge, you can understand Java features. After finishing this topic, we'll go to Java. After finishing interpreter and compiler, next we'll go to Java, right? Yes. See, this is yes, these basics, interpreter and compiler. After finishing about Java starting. About Java starting, Java features and all this here, right? Yes. So let us see about this interpreter and compiler. Yes, interpreter versus compiler. Yes, interpreter versus compiler. Let us see. Yes, anyone have the idea about interpreter and compiler? Yes, anyone, at least one difference. What's the difference between interpreter and compiler? Anyone? Anyone? 1 second. See, if anyone unable to hear me, please rejoin the session. Still someone is offline. Yes, rejoin. If anyone unable to hear me, please rejoin the session. Rejoin the session. If anyone unable to hear me, rejoin the session. This guy, Vinay. Vinay has to resign. Vinay has to resign. Vinay has to resign. Okay. Yes. Interpreter versus compiler. Just anyone, just at least one difference. At least one. Of course, I'll explain very clearly. I'll explain very clearly. Just I'm asking your idea. Yes, what's the difference? Interpreter and compiler. Okay. Vani. Okay. Next, Bharatwaj. Okay. Next, any others? Okay. Yeah, let us start. Let me explain. Interpreter versus compiler. First, let us see about interpreter. Yes, for interpreter-based language, just I'm taking Python. Python is interpreter-based language. Python. So Python source codes. Python source codes. Okay, suppose s.py file. Some Python source codes. So Python source code. Let us go to Python. Yes, Python. Yes. Some test.py file. So D drive Python. Yes, mltra Python. It's located D drive. Yes. CMD, command prompt, command prompt. Yes, D colon, it will take D drive here, DER. Yes, in this mndraw Python, Python location, mndraw Python, CD, yes, mndraw Python, it changed, CLS, DER. Here there is a test.py file, test.py file, test.py file. Yes, how it's working? It's notepad, notepad, test.py. See, 1 second, to develop the Python applications, this ID, PyCharm is there. PyCharm ID. Using PyCharm ID, we can develop the Python applications. Okay. See, for understanding purpose, I'm using Notepad. Just I'm using some Notepad. Okay. So Notepad test.py. So Python script this is. Python script. Yes, A equal 10, B equal 20, C equal to A plus B. So displaying addition. Next, subtraction. Yes, next let's add one more statement. C equal to int B. So next multiplication. Yes, next about multiplication. Multiplication. Save. Yes, save and exit. Yes, next let us run this Python here. See Python script running directly here. Python. Yes, I'm not checking any errors. Without checking errors, get directly submitting Python script. Yes, no checking errors. Suppose C program is first will compile, will check for all the errors. If it is C program, first of all, will check for all the errors. If no errors, running C program, right? But when come to Python, no errors checking, directly running program here. The script directly submitted and executed. Yes, no errors checking, nothing. Directly executed. The source code executed directly. It's a source code. Test.py is a source code. Yes, the test. It's a Python script. It's source code. The source code executed directly. Source code simply executed. Okay. Yes. 1 second. Yes, that source code executed directly. Right. Suppose there are mistakes in script. What happens here? There are some mistakes. Suppose here comma missing. Okay. Suppose here one more statement. Suppose double quotation is missing. Suppose here yes bracket missing. What happens? Let us see. But there are yes some mistakes, right? Some mistakes in the program. What happens here? Yes, in the script, Python script, some mistakes. What happens now? Run it here. Yes, running. Yes, running that script. See this. Yes, these error messages. Addition. Yes, here it's error message. Yes, here only error showed. Only one error. So what's happened here? What's happened in Python here? So how that interpreter works? Python is interpreter-based language. Python is interpreter-based language. Yes, how it works here. So by interpreter first checking for the first statement. Yes, first statement is correct. First statement is correct. If it is correct, immediately executes. What happens here? Syntax is correct. So A equal to, for A memory allocates storing 10. B this also correct. Memory allocation storing 20. C equal to A plus. So calculating the result assigned is C. So complete it one by one statements. Line by line. First line checking and execution completed. Next line checking execution completed. Next line checking and execution also completed. Next here error. Once error comes, simply stops. Once error comes, simply stops. Okay. See how interpreter is working. See interpreter working is like this. Yes, let me explain very clearly. Interpreter, how interpreter is working. See interpreter. Yes, Python is interpreter based language. Yes, how it's working. Let us see how it's working here. See interpreter based language. Suppose first line here. Yes. Next line. Yes. Next line. So interpreter based language. Next line. So next statement. So Python script. Interpreter based language. Python or HTML script or Linux shell scripting. Yes, Linux shell scripting example also discuss. One more example. Interpreter based language. Interpreter. So next line. Okay. Yes. Next line. Right. Yes. Next line. Like this. Next line. Yes. All the lines like this. Suppose this is script. Yes. How interpreter working on this? How interpreter working on this? See, interpreter checks the first statements. Interpreter checks the first statements. After checking first statement here, if syntax is correct, Immediately it converts into binary code. Yes, immediately converts into binary code. Zero response format. Zero response format. Just converting to binary code. Checking for the first statement. If first statement is correct, yes, immediately converts into binary code. Just immediately converts into binary code. That binary code simply given to processor. Yes, binary code given to processor. So binary code is simply given to yes, a processor, right? Yes, processor taking generating output. That's it. Our first statement completed. Okay, interpreter checks the first statement. Yes, if first statement is correct, if it is correct, simply converts into binary code. That binary code given to processor. So processor generating output. So over first line completed. See, next coming statements may be right or wrong. Never think about next coming statements. So never think about next coming statements. Next coming statements may be right or wrong. Never think about next coming statements. Okay, first statement is correct. Immediately converts into binary code and given to processor and generating output. So first statement completed. So first line completed. Yes, after that checking for second line. Checking for second line. Suppose second line also correct. Same process. Second line also correct here. Same process. Same process. Same process here. Second line also correct here. Same process. Converts into binary codes and given to processor generating output here. Suppose something wrong at third line. Yes, something wrong at third line. Simply stops. Simply stops. That's it here. So this is working of interpreter. Any error comes, simply stops. If any error comes, simply stops. Yes, it shows only one error. Yes, interpreter shows only one error. If any error comes, simply stops. It's line by line. Line by line, checking then execution. Checking first and then execution. Checking second and then execution. It's line by line. If any error comes, simply stops. Simply stops. Now, let us correct this error. Yes, let us correct this error. So this one, seventh line error, right? That seventh line error. Yes, correction done. Seventh line error. Okay, after that, now let us run 1 second here. Yes, let us run this. Let us run this. Yes, now 11th line error. Means it's showing only one error. Not all the errors. It is showing only one error. It is showing only one error here. Okay, interpreter shows only one error. Now let us correct this error also. So this statement is error. Line number 11. Line number 11. Line number 11. Okay, yes. So this statement. Let's save. Save and exit. Save and exit. Yes, now try it. Yes, next error. Yes, 18th line error. 18th line. So like this here showing only one error. Showing only one error here. It's not showing all the errors. Only one error. Right? Okay. Save. Yes, now run it. Yes, save. Run it. Yes, save. Run it. Yes, now it's working. Fine. That's it. So this is working of interpreter. Yes, interpreter working is like this. So interpreter checking program line by line. Line by line, checking and execution line by line. Yes, if any error comes, simply stops. If any error comes, interpreter stops. Any error comes, interpreter stops. So this is working of interpreter. Right? Okay. Yes. Now let us take compiler. How compiler is working here? For compiler purpose, let us take C program. Yes, Linux. Linux. Yes, in real time, generally using Linux based C program. Okay. In real time, Linux based. Yes, no one using Turbo C, Linux based. So let us see that Linux based C program. Okay. Yes, compiler. Yes, if it is compiler, how it's working. Let us see about compiler also. Compiler. Yes, how compiler is working. Yes, compiler. Yes, compiler. For compiler, yes. For compiler, let us take C program. Test.C program. Test.C. C program. Compiler based. Test.C. 1 second. Let us log in. Demo. Yes. Compiler based. Yes, how compiler based is working here? Compiler. Compiler first of all checking for the first statement. Suppose first statement is correct. Suppose first statement is correct. Suppose first statement is correct. First statement is correct. Even it's correct here, it won't convert into binary code. No. It won't convert into binary code. No. Yes, second statement is correct. Even correct, it won't convert into binary code. So what happens here? First of all here, top to bottom checking for all the errors, checking for the all the mistakes here, checking for next statements. Suppose something wrong here, error at third line. It shows that error at third line. After that, checking for next statements. Okay, next, checking for next statements, checking for next statements. like this top to bottom. Compiler checks all the statements from top to bottom and shows all the errors. So next statement. So next statement checking here. So next statement checking. Okay. So next statement checking like this top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Compiler shows all the errors from top to bottom. It checks all the statements from top to bottom, shows all the errors. All the errors, right? Yes. No. You have to correct all the mistakes. Correction of mistakes. So next you have to correct all the mistakes. After correction of mistakes, here recompile. Suppose next time correct. Okay, next time everything is fine. So next time everything is fine here. Everything is fine. Then what happens here? Yes, if no errors. If no errors. So compiler checks the whole program from top to bottom and shows all the errors and shows all the errors. If no errors, then what happens? Let us see. If no errors here, what happens? Then compiler opens another file. Yeah, this one I'll show practically. Compiler opens another file here. Compiler opens another file. Yes, after opening another file here, after opening another file, yes, all the statements converts into binary codes and write to this file. Yes, all the statements converts into binary code like this. Converts into binary code. Curious ones forward. All the statements converting into binary codes. All the statements just converting to binary codes. Okay, every statement top to bottom. Yes, all the statements converts into binary codes. All the statements convert into binary codes and write to another file. Write to another file. Yes, this file, this result file is called as exe file. Exe means executable file. Exe means executable file. Okay, exe means executable. Yeah, this exe file. Yeah, this exe file simply given to processor. This exe file given to processor. Processor. So processor taking that exe file and executing top to bottom at a time. Executing all the statements at a time, generating output simply. That's it. So what is main difference observed here? Exe file. Exe file here observed, right? So in case of interpreter, what happens here? So first line converted, executed. Second line converted, executed. Line by line. Line by line conversion, then execution. Conversion, execution. But compiler, what happens here? All the statements top to bottom. Checking all the statements from top to bottom. If no errors, generating one exe file. Generating one result exe file. But here there is no exe file. Here don't have any exe. Line by line. Conversion, execution. Conversion, execution. But here compiler generating one exe file. That exe file given to processor. Processor finally generating outputs. Okay. Yes. Finally generating outputs. Yes. Now 1 second. Let me show practically. Let me show practically that compiler. Yes. Yes, Mr. Bharadwaj, just wait. I'll explain about object file also now. Let us see object file also. CD suppress mn directory. Yes. Present working directory mn ls. Yes, remove. Okay. Remove all the files. Remove here. Yes. gedit test.c program. gedit test.c program. Test.c. Yes. Hash 1 second. Yes. Hash includes std IO data. std IO data. Hash include std IO data. Next void main function. Yes, starting ending. Yes, in this same addition, subtraction, and multiplication. Yes, int. Yes, int a is equal to 10. Okay, right? Next statement. Yes, int b is equal to 20. Yes, next statement. Int c results variable declared. That int c equal to here. Yes, a plus b, right? A plus b. Yes, printf. Printf. Yes, addition value. Yes, addition. Yes, addition equal to yes personality slash next time comma c this thing c value. So this is addition, right? Yes, after that subtraction, next multiplication. So addition, next subtraction, minus subtraction. Yes, subtraction. Subtraction is next multiplication. Yes, multiplication. Multiplication. Yes, multiplication equal multiplication. So this is C program. Okay. Yes. So addition, subtraction, and multiplication of three numbers. Program to perform these three operations. Okay, let's start the program, right? Now let us compile this compilation GCC-C. Yes, it's a C language compiler. GCC-C test.c compiling right? Yes, compiled. No error message. See, on test.to file generated. Test.to file generated. This test.to file contains what binary code. Binary code for your C program. After that, now GCC. Next step is GCC -o. GCC -o some project. exe file name is project. Test.o. Now the test.o file converting to exe format means ready to execute. This object file is not ready to execute. Okay, finally preparing one exe file. Preparing some exe file. Okay, right? Yes, exe file created. The project is the exe name. Result exe. This exe name can be anyone. You can give any name. Any no issue here. Now executing project exe file. Project exe file. Right? Addition, subtraction, multiplication is equal to 1 like this. Addition value, subtraction, multiplication. That's it. So these are the steps in this. There are the steps here. So creation of exe. This is project is exe file. That exe file. So exe file contains what? All the binary codes. Let us open that exe file. Yes, project exe file. It will take little bit time here. Project exe file. That contains all the binary code. Zeros ones format. It's a system understandable language. See this? System understandable language. It's a machine language. Zeros and ones format. It's a system understandable language. It's exe file. It's exe file. It's exe file. It's exe file. Okay. That project exe file created. Yes, that project exe file. Yes, executing it. Okay. See, same explain here also. Yes, no errors from top to bottom. If no errors, generating one exe file. Nothing but the project exe file. Project exe file generated, right? That exe file given to processor, then executor finally giving output. This is how compile is working. Suppose for some mistakes. 1 second. Yes. Remove start.file. Remove here ls. Okay, let's z-edit test.c program. Suppose some mistakes. Suppose here semicolon missing. Okay. Suppose here bracket missing. Suppose here some comma missing. Suppose here semicolon missing. Okay. Suppose here double quotation is missing. Something is missing. Save. Save and recompile. No compiling again. Save this. Yes. GCC-C test.c. Yes. See this. All the errors. See this. 9th line error. 11th line error. 13th line error. 17th line error. Yes. Next. Yes, 21 line error. All the errors from yes, 22 line number 22. Yes, all the errors from top to bottom. Right. Same point explained here. So compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom, shows all the errors. Interpreter is only one error. See, in case of interpreter, any error comes, interpreter stops. Any error comes, interpreter stops. But compile is not like that. Compile is not like that here. Compiler checks all the statements from top to bottom and shows all the errors. All there. See that top to bottom, all the errors. See this. All the errors from top to bottom. All the errors. All the errors from top to bottom. Top to bottom. Okay. Now let us correct mistakes here. Yes, semicolon missing here. Yes, here. This bracket missing here. Okay. Yes. Suppose here this is yes double quotation missing. Now save. I think still mistakes are there. Yes, GCC compare still mistakes. Yes, 17th line and 21st. Two more errors. Two more errors. Two more errors. Okay, two more errors. So here comma missing. Here comma missing. Here semicolon missing. Right? Semicolon missing. Right? Let's see this. Still the test.to file not generated. Not generated. No compiling. Yes, no error. Test.to file generated. After generating test.to file, GCC-O, the test.to file, object file, converting to exe format. Exe name can be, suppose exe name Durga. That name can be anyone. Exe name, right? Yes, convert to exe file. See what happens here. At the time of creation of exe file, what happens here? Durga, exe name is Durga, right? This exe, how it generates? See here, for creating exe file here, compiler taking your program test.o. So this is C program test.o. C program test.o file links with OS library. Of linking with OS library, generating exe file, generating exe file, generating exe file. Now let us run this. Yes, that's it. Got it out. So this is working of yes, compile like this. So this is difference between interpreter and compiler. Difference between interpreter and compiler. Let us see points wise. Yes. Yes, interpreter. One more example also you can see here. One more example. Suppose one more example. Gedit. Yes. Suppose math shell script. Math mill operation shell script. Suppose A equal to 10. Yes. B equal to 20. Okay. Echo. Yes. Echo addition value. Yes. Addition. Yes. Addition equal to here. Yes. EXPR. Yes. Dollar A plus dollar B. Dollar B. Dollar B. Okay. Right? Yes. Echo. Yes. Subtraction. Subtraction is equal to here. Yes. EXPR. Yes. Dollar A. Yes. Dollar B. H. Subtraction. Echo. Yes. Multiplication. Yes. Multiplication. Yes. Multiplication is equal to here. Yes. Yes. EXPR expression. Yes. Dollar A. Yes. Backslash star. Yes. Dollar. See here. General shell scripting Java is in my fingertips only. Regularly you say this shell scripting. Yes, regularly I'll be working on shell scripting, Java, Python, Hadoop big data. This area, my area of experience. Okay, on fingertips and coding. So without mistakes, I can do the coding. Java, shell scripting, next Python coding, and next Hadoop coding. It's on fingertips only. A value, B value. So addition, subtraction, and multiplication like this. Save and manage. Yes, see this. No comparison process, directly running. See math.sh, shell script. Yes, bash. Bash is the interpreter. Shell interpreter. Yes, like Python interpreter, shell interpreter is bash. Bash is interpreter. Yes, math.sh, right? Yes. Somewhere error. See this. 1 second. Subtraction. Yes, dollar $A minus dollar $B. Expression echo subtraction. Echo multi. Yes, here. What is missing? H. Yes. Yes. Clean clear. Yes. Now bash. 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 C. Math.sh script. Right. Yes. Executed successfully. Executed. Right. Suppose let us do some mistakes here. Suppose A equal to 10, B equal to 20. Yes. Addition equal to. After that, let us do some mistake here. Subtraction. Here mistake. What happens? A equal to 10, the statement executes. B equal to this also executes. Interpreter. First statement executing, second statement, third statement. Yes, output of third statement also getting. Yes, when come to the statement, error message simply stops. Here stops. Here stops. Here stops. Okay. Yes, now see this. Yes, how it's working. See that addition equal 30. So displayed. So what's happened here? Yes. So next 10th line error. 10th line error. Addition equal 30. Addition equal 30. Addition equal 30. That means this statement executed, this statement executed, this statement executed. Once error comes to be stops. This is working of interpreter. So how interpreter is working here? Checking line by line. Okay. Checking first statement correct. Yes, executes. Okay. Yes, second line correct. Executes. Third line something wrong, simply stops. Same here also. So first line is correct, executed. Next line correct, executed. Next line correct, executed. Yes, here something wrong, simply stopped. That's it. That's it. So this is working of interpreter and compilers like this. Working of compiler, interpreters like this. Now let us see points wise here. For clear understanding purpose, let me compare this. Yes, let us see. Interpreter and compiler. What's the differences here? Interpreter, yes, and compare the differences. Yes, yes, interpreter, yes, interpreter, interpreter, next compiler, interpreter, compiler. What's the difference here? Interpreter and compiler. So what's the difference between these two? Let us see the differences. Interpreter, first difference, yes, it checks. Yes, it checks the code. It checks the code line by line, right? Yes, line by line. Yeah, that should practically here. Checking first line. Yes, then conversion then execution, right? First line checking, then execution. Next line checking, then execution. What is compile here? Yes, whole program. Compile is yes, whole program from yes top to bottom, from top to bottom, from top to bottom. Whole program from top to bottom. Okay, so interpreter checks the program line by line. Yes, it checks the program. Yes, it checks the code line by line. Yes, compiler whole program from top to bottom. Right. Next. Yes, output. When come to output here, yes, it generates. Yes, output. It generates output line by line. Line by line. First line checking. Yes, if it is correct, generating output. Second line correct, generating output. Third line correct, generating output. Next line back, simply stops. But when come to compiler here, yes, at a time output. In case of compiler generating one exe file, that exe file executing at a time, right? So at a time generating output. So this at a time output here, it's a at a time output, at a time output, at a time output, right? Yes, next difference. Yes, interpreter. If any error comes, simply stops. That means it shows only one error. It shows only one error. It shows only one error, right? Only one error. Compiler, all the errors. It shows all the errors. Errors from top to bottom. All the errors from top to bottom. From top to bottom, right? Top to bottom. Right. Yes. Interpreter shows only one error. Interpreter shows only one error, but compiler shows all the errors from top to bottom. All the errors from top to bottom. 1 second. 1 second. Let me have some water. Yes, next. Yes, here, main important point here. Yes, interpreter, yes, does not generate exe file. It does not. It does not generate. It does not generate exe file. It does not generate exe file. Yes, compiler, it generates exe file. Generates exe file. Generates exe. These main difference. So this is main difference between interpreter and compiler. What is main difference here? The compiler generating one exe file. That exe file executes. Okay, that exe file executes. Okay, yes, compiler generating exe file. That exe file executes. Okay, so interpreter does not generate exe file. No exe file. Okay, right? See, interpreter, see, it executes source code directly. It executes source code directly here. It executes source code directly here. It executes source code directly. Yes, executing source code. See this. Python scripting, directly source code executing. No errors checking, nothing here. No exe file. Just directly test.py. That scripting executing directly here. The script executing directly. The script executing directly here. Yes, here also. Here also here. Shell scripting. Linux shell scripting. It's interpreter based language. So here also directly script executing. No exe file. Directly source code. This is called source code. See, your program called as source code. This is called as source code. So what are the program we are writing? Our program is source code. So the source code executes directly here. So here interpreter, source code executes directly here. It executes source code directly here. Then come to compiler here. Yes, compiler. Yes, it executes exe file. It executes exe file. Yes, it executes exe file. So compiler based executes exe file. Okay, interpreter based, it executes source code only here. Source code directly executing, no exe file. Yes, compiler, it executes exe file. Yes, next difference here. See, interpreter. Yes, all scripting languages comes under this category here. All scripting languages comes under this category here. So these are programming languages. Yes, interpreter based language called as scripting languages. Okay, compiler based language called as programming languages. Okay, scripting means that can be modified anytime. Scripting can be modified anytime. But programming you cannot modify. So once build is created, you cannot modify. Script anytime you can modify. Okay, anytime we can modify. Okay, see, suppose Python script here. Yes, suppose I don't want this multiplication. Simply I can remove. I can submit code directly here. Yes, in real time also same. We can modify that code, you can submit. Okay. Suppose again if you want to add it, you can add it. Just add it and run it here. Add it, run it. So directly. But when come to yes, when come to here, yes, C compile based. C is a compile based. Suppose I want to modify the code. That exe file. No. The Durga exe file I can't modify. We can't modify. Then what's the way? We should modify the source code. Source code you have to modify and you have to rebuild again. Again you have to regenerate exe file. So means directly cannot modify. Directly cannot modify. Okay. That's the meaning of scripting. Scripting means that can be modified anytime here. HTML scripting, Python scripting, Linux shell scripting, that scripting anytime you can modify. Anytime you can modify. That is meaning of scripting here. Scripting means that can be modified anytime. Okay. Yes, scripting language examples. Scripting language examples here. Yes, just example Python. Python is a scripting language. Next HTML is scripting language. Linux shell scripting. Shell is a scripting language. Shell is scripting language. Next PHP is scripting language. Next Perl scripting. They are scripting language. These are scripting language. Okay, they are scripting language. See 50 points. See, it executes source code directly. Source code executing directly. Source code means see gedit math.sh. This is called as source code. This is source. This is called as source. This is called as source. This is called as source. Okay. Yeah, this source code directly executing. No errors, nothing checking it. Directly executing. Source code executing directly executed. Source code executed directly. See in Python also. See this. Python. This is Python source code. This is Python source code, right? This is Python source code. Yet this code executing directly here. This code executing directly here. This code executing directly. But when come to compiler based, these are interpreter based. Yes, Linux shell scripting. Next Python scripting interpreter based. When come to C language, yes, C language. Yes, if it is C language, in C language what happens here? Exe file execute, not source code. You cannot execute test.c file. You cannot execute. This test.c file has to convert into exe file. Yes, convert into exe file. Yes, the Durga exe file. That is a 50 point meaning here. That exe file executes directly here. Here exe file. Here it's exe file. Now compiler based exe file executes. Compiler based exe file executes. Compiler based one is exe file executes. Okay, right? Yes. Yes, if it is interpreter based, it executes source code directly. Executing source code directly. Compiler based exe file executes. I think it's clear. Yes, how it's clear, right? Yes. Yes. Interpreter. Yes, execute source code. This exe file execute. That's it. Okay, directly your program executes means source code. But in case of compiler generating one exe file, after generating exe that exe file executes. Okay. See interpreter and compiler differences. Interpreter checks the code line by line, checking first line then execution, checking second line then execution. It's a line by line checking. Okay, next output also line by line. When come to compiler here, yes, checks the whole program. Yes, whole program from top to bottom. Yes, compiler. See compiler. Yes, it checks whole program from top to bottom is all the lines. All checking all the lines. Okay. Yes, if no errors, generating one exe file. So output at a time output. Interpreter based is line by line output here, but compiler based at a time output. Yes, next interpreter shows only one error. Any error comes, interpreter stops. Compile is not like that here. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Okay, right? Yes, next main important difference is fourth one. Okay, fourth point is very important here. See, interpreter does not generate exe file. Interpreter does not generate exe file. See this interpreter directly code executed, directly source code executed. But in case of compiler based, what happens here? That exe file created, one exe file created. Okay. See here, remove, yes, p star, yes, yes, 30, sorry, rm, yes, t star, Durga exe file removed here, remove star dot, yes, removed here, see, test.c file, see this test.c file, you can't execute directly here, yes, gcc-c test.c file, compilation, yes, compiled, we got one test.2 file. Now this test.2 file we should convert in exe file. GCC -o. Yes, suppose exe is project here. Test.2. This test.2 file converting the exe file. That exe result exe is green color is exe file. Project exe file generated. That project exe file generated. Yes, after that, run it. Yes, we got the output. That's it. We got the output. Yes, finally we got one exe file, project exe file generated. Project exe file generated, that file execute, right? That's it. Okay, like this no exe file concept. See, if it is Python, directly Python script executing, no exe file. Yes, when come to compile the base, C is a compile the base, here exe file generated. That test.c, your source code converted into one exe file, that exe file executed. That's it. This is main difference between compiler and interpreter. Okay, see here, interpreter checking first line, if it is correct, immediately converts into binary codes, then given to processor, so getting output here. Second line checking, if it is correct, converts into binary codes and given to processor, generating output. So line by line, this is line by line. Suppose any error comes, simply stopping there, any error, simply stopping there. But compile is not like that here. When come to compile here, checking first statement, yes, next statement, next statement, next statement. Yes, checking all the statements from top to bottom and shows all the errors. Suppose if no errors, generating one exe file. Yes, generating one exe, that exe file submitted to processor. So processor taking exe file, then executes, finally giving output. Finally giving output here. Okay, see this result file is a difference here. See, in case of interpreter, don't have that result file. Line by line executed. Line by line executing here, but no exe file. But here this is exe file. This is main difference. So this result file generating, that project exe file generated. Project exe file generated. Just generated one project exe file that executes. So this is main difference between compile and interpreter here. So main difference here. Okay. Yes. Fourth one. Yes, it does not generate exe file. It generates exe file. Right, okay. Yes, it executes source code directly. Source code executes directly here. It executes exe file. It executes exe file. See, all scripting languages are interpreter based language. All programming languages are compiler based. Scripting language examples. Yes, Python, HTML, shell scripting, PHP, Perl scripting. These are scripting languages. Scripting language. Yes, programming language examples. Compiler based examples. C is a compiler based, right? Next C++ is a compiler based. Next .NET C# is a compiler based. These are compiler based languages. Right, okay? Yes. See, interpreter based language. Yes, interpreter based language don't have exe file concepts. Okay. Yes, interpreter based language. Yes, interpreter. Yes, interpreter based language. Yes, interpreter. Yes, interpreter based language. Interpreter based language don't have, yes, don't have exe file, don't have exe file. Okay, here everything is exe file. Everything is an exe file. Everything is an exe file. Exe file. Okay, yes. So interpreter based language don't have exe file. Here everything is exe file. So finally getting one exe file and executing. I think you understand about exe file, right? Yes, I think it's clear that exe file concept. Yes, still we have one more topic on exe file. What is exactly exe file? We'll discuss. Wait. Next, one more difference here. See, scripting language. Scripting language can be modified anytime here. Yes, scripting language. Yes, it is an open source. It's an open source. Open source means that can be modified anytime here. It's an open source. It's an open source. Yes, it can be modified. It can be Yes, modified. It can be modified anytime. It can be modified anytime. Source is open source. Python scripting, anytime we can open and anytime we can modify. Linux shell scripting, anytime we can modify. But when come to programming language, once exe build created, you cannot modify. Suppose really if you want to modify this, that build project build here, really if you want to modify this, first you have to modify the source code. After modification of source code, next you have to rebuild the exe file. So once rebuild the exe file, you can run it here. So directly cannot modify. So directly cannot modify the programming. This is not a open source. Yes, not an open source. Not an open source. Not an open source. Not an open source. Okay. Not an open source, cannot be modified. Cannot be modified. Cannot be modified. Okay. See, open source means that can be modified anytime. Open source means that source code can be modified anytime here. But here, compiler based programming language, these are not open source. Cannot be modified. Cannot be modified, right? Yes. So this is difference between interpreter and compiler. So different. Main difference is exe file. See, interpreter based language don't have exe file. No exe file. Directly, that Python script executing directly here. Okay. Suppose Linux shell scripting. Yes, that shell scripting executing directly here. Okay. Math, that is shell scripting. Next, one more example. Yes, suppose HTML script. Suppose login.html file. See, login.html. Login HTML file here. It's HTML. HTML file. Yes. Open with notepad. See, this is HTML script. Okay. Yes, this script you can run directly here. Just double click and opening. HTML is a browser understandable language. Directly HTML script executed. See that login form. Login form, right? Login form, right? Directly executed. No errors checking, nothing. No exe file concept. No exe file, no executable file here. Directly source code executed. The .html file executed directly here. Okay, the .html file. .html. That HTML file executed directly. No exe file concept. So interpreter based language don't have exe file. Interpreter based language don't have exe file concepts. Okay. I hope everyone you understand, right? The difference between interpreter and compiler. Yes, you understand clearly. Interpreter and compiler differences. Yes, is it clear? I think Kaur, yes, you joined late, I think. Something, some delay in joining, I think you. Yes. Yes, I think, I hope everyone's clear. Interpreter and compiler. Now here, something surprising here. Some surprise. Here we are talking about Python, C language, C++, and .NET, many things. Where is Java? Okay. Yes, where is Java? Now Java comes on what? Yes, I'll share the recording. Don't worry. Okay. Yes. Now where is Java? Java comes under what? Java. Is it compile based or interpreter based? What is Java? Let us see. Yes, Java, is it compile based or interpreter? That is the actual main point. Yes, let us see about Java. Okay. See, about Java, I will explain. Yes, about Java, I will explain. You have to decide. I'll explain. Based on my explanation, you have to decide. Based on my explanation, you have to decide. Just you decide. I'll explain about Java. Okay, finally you decide it. 1 second. 1 second. 1 second. See, for our patch, already WhatsApp group created. Yes, last 2 sessions videos already shared in WhatsApp group. In WhatsApp group created for our batch. See, batch. Yes, 6 p.m. batch. See, this is yes, 14th session and 15th session. These are yes, already shared. Yes, open and watch it. You can watch it. Here you can watch. Open and watch. Here shared in group. I'm sharing. Not only group here, next year I have created drive also. For our batch, separate drive created. Okay. Yes, I'll add it. Just a minute. I'll add it. For our batch, separate group created. For our batch, 3, 4, 5, 6. Is a drive also created for our batch? No, not this one. 1 second. So this is drive for our batch. 6 p.m. September course hour. Yes. Yes. Last two classes sessions already uploaded. Okay. Yes. Sharing this drive level. I'll share this drive from this you can access. For the time being, see. For the time being, see share here. From this I can share to you. The drive level. The drive. I'll give the access to drive. Directly you can read. Yes, you can watch from the drive. Directly you can watch from the drive here. Directly you can watch from the drive here. For the time being here, just link is generated. Link is generated. For the time being, link is generated. That link is shared with you. So here for the time, just generate get link. Yes, link to that recording shared. Okay, yes, this drive, I'll share it. Okay, this drive, I'll share it. Okay, these links, yes, shared already this. For the time being in WhatsApp group. I'm using WhatsApp group here for sharing this recording here. Okay, from next class onwards, drive level link I'll share it. Drive level. So every day uploading to this drive. Yes, you can watch from this drive. Yes, this drive level I can share to your Gmail ID. I'll share to your Gmail ID. So once share to Gmail ID, go to Google Drive. From that you can watch it. From the Google Drive you can watch it. Okay. Yes. 1 second. Yeah, this is my WhatsApp number. Just share your details. 81789123. Share your details. Share here. Yes, name. Yes, I will add to that group. So name. Yes, next WhatsApp course you are attending here. Next WhatsApp time you are attending here. Time you are attending here. Next Gmail ID required compulsory. Gmail ID. These details. These details share to my WhatsApp number. Share to WhatsApp number. Not here, not in public chat box here, not here. Share to this one. Share to this. This is my WhatsApp number. Share here. Share to my WhatsApp number these details. I'll add to group so that you can get every alerts. Yes, minute to minute communication. I'm using WhatsApp for the minute to minute communication. Yes, immediately I'll respond. Okay, it's not like other trainers. I'll respond immediately. Minute to minute response. Every minute I'll be responding here. Immediate response here. Okay, take this number here. Yes, share these details. Okay, see, this is my number. Please note it. Still anyone pending are there, please submit. Yes, I think already 20 members submitted. 20 members they have submitted details. Okay, I think maybe only 2 or 3 members are pending to submit details. Okay, yes, I think almost everyone is in group except 1 or 2 guys. Everyone is in group here. Information time to time. Okay, so I'm using WhatsApp for the best communication purpose. Yes, you can ask doubts in groups or personally also. So yes, in my personal window also you can talk to me, no problem. Okay, or voice calls of same number I'm using. Yes, anytime you can talk to me. Just call to me. Yes, I can respond. Okay, yes. Now let us continue. Yes, yes. Duration 75 days. Duration is 75 days. Daily 1.5 hour class. 6 to 7:30 class. Okay. Yeah. So this is about interpreter and comparer. Now let us come to Java. What is Java? Yes, about Java I will explain. Yes, you have to decide. Explain. Then finally you have to answer that. Yes. 1 second. See, except Java. Except Java, other languages. In other languages, what happens here? Except Java, other languages. What happens here? Source code. Source code. Source code. Suppose C program. C program source code converts into binary code. C program source code or Python source code. Yes, except C language, other languages. Source code converts into binary code. Source code converts into binary code. That binary code given to processor. That binary code given to processor. Right? Finally generating output. Finally generating output. So this is what is happening in other languages except Java. Except Java. Except Java, source code converts into binary code. That binary code given to processor generating finally output. Generating finally output, right? Okay. Yes, if it's Java, what happens? Yes, in Java, what happens here? In Java, first of all, source code. First of all, source. Okay. Yes, sir. Kaur, I think already spoke to me. One day spoke to me. Yes, in morning batch you attended, I think 8:30 batch. Same 8:30 batch and this batch. Myself 8:30 also myself only morning batch. Same as that, no difference. Yes, source code. Source code converting into yes byte code. In Java, what happens here? Source code converts into byte code. That byte code converts into yes binary code. Yeah, definitely. One in sure. I can share. Okay. Just remind me. Yes, in WhatsApp. Yes, I think already joined in group. You are there in group. Just you remind me. I'll give the link. Okay, I'll give the link. Okay. Yes. 1 second. 1 second. Let me record the session. Yes. Recording. So 1 second. Just a minute. Okay. Yes. See, except Java, other language like this. In Java, what happens? Let us see. In Java, what happens? In Java, what happens? First, source code converts into byte codes. That byte code converts into binary codes. That byte code converts into binary codes. Okay. Source code converts into byte codes. That byte code converts to binary codes. That binary code given to processor. Binary code given to processor generating outputs. Finally generating outputs. Okay. Yes. So in Java, what happens here? Source code converts into byte code to binary code given to process generating output. Yes, in Java, byte code introduced. Some byte code introduced here. Okay, byte code, some intermediate code here in Java. Some intermediate code is introduced here. Intermediate code. Why byte code introduced here? To make the Java as independent. Byte codes. Main purpose of byte code is to make the Java as independent platform. To make the Java as independent platform, byte code was introduced. To make the Java as independent platform, that byte code was introduced. Byte code was introduced. Okay. bytecode was introduced. Okay, yes. So this is now here. See, in case of other language, source code to bytecode, source code to bytecode, either compiler or interpreter, either compiler or interpreter. Only one thing, either compiler or interpreter. Only one. Yes, will convert source code to bytecode. Either compiler or interpreter, either compiler or interpreter converting from source code to binary code. But when come to Java, what happens here? Source code to bytecode, source code to bytecode. Yeah, this is by the Java compiler, Java C, Java compiler. So Java compiler. Okay, yeah, Java compiler. So converting with Java compiler. Source code to bytecode by Java compiler. Right, okay. Next bytecode converting into yes. Yes, the bytecode to binary code. This is by the Java interpreter. Java interpreter. Java interpreter. Java interpreter. Okay. Java interpreter. Java interpreter. Right? Yes. Source code to bytecode by the Java compiler here. Yes. Bytecode to binary code by the Java interpreter. In Java, what happens here? Yes. Error checking by the compiler. Error checking by the compiler. Error checking by the compiler. Okay, in Java, what happens here? Errors checking by the compiler. In Java, errors checking by the compiler. Okay, yes, if no errors, generating, yes, bytecode file, dot class file, called as dot class file. It's a bytecode file, generating one dot class file, just generates one dot class file, generates one dot class file. Okay, but as bytecode, it's a bytecode file, it's a bytecode. Generates bytecode file. Okay, so errors checking by the compiler. In Java, errors checking by the compiler. If no errors, generating dot class means bytecode file generating, right? Bytecode file generating, right? After generating bytecode here, yes, runtime. Yes, 1 second. Let me show practically Java also. D drive cd / cls cd test. Yes, dir. Yes, in this test. Yes, test.java. Yes, notepad. Yes, 1 second. 1 second. Del dot class. Dot class remote here. So here they said test.java file is there. Yes. D drive. Some test folder here they said test.java. D drive test folder. D drive test folder. Exit. Command prompt. Opening command prompt. D colon we take to D drive. Here. In D drive, they say test directory, test folder. Directory folder both are same. CD test changed CLS. Here. Now they say test.java. Yes, no. Notepad. Yes, test.java. Like your Python scripting, here also using Notepad writing Java program. Okay. So actually in our class using Eclipse every day, not Notepad. Only for understanding purpose, just now I'm using Notepad here. I'm using Notepad. Okay, just only for only for understanding purpose I'm using Notepad. Actually, we'll be using Eclipse only here. Yes, Eclipse in real time also using Eclipse. So regular classes using Eclipse. Okay, now so Notepad test.java. Yes, it's open test.java program. So this is public classes, public static void main. Yes. Suppose here there is a hello world. Hello world program. Save and exit. Save and close. No. Dir. Correct. The test.java. Yes, Java compiler. No Java compiler. Test.java. Java compiler test.java. Yes, compiles. After compilation, DRC is test dot class file generated. See, dot class file is a bytecode file. Test.java is a source. Okay. So what's happened here? So first, so error checking by the compiler. So what happens first? Test.java. Test.java. So this is given to Java C compiler, Java compiler, right? Test.java given to Java C compiler. So Java C compiler taking test.java compilation, if no errors, generating. Yeah, this is source code. Test.java. Yes, it's a source code. Source code. Yes, it's source. This is source code. It's a source code. Okay, test.java is a source code file. This is. So test.java, it's a source code. This is source code. So the source file, source code file given to Java C compiler. Okay, Java C compiler taking test.java, if no errors, generating bytecode, bytecode, right? Bytecode, it's a tested dot class. So generating one bytecode for test dot class, right? Test dot class. After generating bytecode here, so this bytecode file tested dot class file. Okay, so Java C means Java compiler. Java compiler checking for all the errors. Test.java checking. If no errors, generating one bytecode for tested dot class file, right? Now this tested dot class file. No, let us see. Tested dot class. See tested dot class file, right? Now Java test file. Enter. Yes, now here interpreter work. Yes, here compile worked. Yes, error checking by the compiler. Program execution by the interpreter. Program execution by the interpreter. Correct? Yes, bytecodes. Tested dot class for given to Java. Yes, it's interpreter. Java interpreter. Java interpreter. Yes, Java interpreter. But Java interpreter, right? Java interpreter. It's interpreter. Okay. See here, Java sims compile. So first compiled invalid. Checking for errors. If no errors, generated one dot class file. Generate one dot class file. After the dot class executing by the interpreter. So error checking by the compiler, runtime by the program execution by the interpreter. Program execution by the interpreter, right? Interpreter. Okay. So interpreter taking dot class file. Yes, in the dot class file kind of statements, not line by line. Now runtime interpreter line by line. So interpreter taking first line from the dot class file, converts into binary code, then executes. Second line converts into binary code, then executes. Third line converts into binary code, executes. So you get generating binary. This is converting to binary code. Okay, binary code. That binary code given to processor. Processor, right? So processor generating output finally. That's it here. Processor generating output simply here. Okay. So what is happening here? So first compiler, error checking by the compiler. So errors. Yes, in Java, error checking by the compiler. Yes, 1 second. In Java, what is happening here? Error checking by the compiler. If no errors, generates one dot class file, bytecode file. So correct? Yes. Next, program runtime. Yes, runtime means execution. Yes, runtime by the interpreter. So runtime program execution by the interpreter. Yes, runtime by the interpreter. Runtime by the interpreter. That's it. Runtime by the interpreter. Yes, runtime by the interpreter. Program execution by the interpreter. See error checking by the compiler. Errors checking by the compiler. Okay. Yes. Source code to bytecode by the compiler here. Bytecode to binary code by the interpreter. So runtime interpreter involving. So if it is interpreter part of a line by line, same that line by line. So interpreter taking tested dot class file, converting first line into binary code, then execution. Second line conversion, then execution. Third line conversion, then execution. That's it here. So this is what is happening in Java here. Okay. So what is happening here? Yes. So here first compilation process. Error checking by the compiler. Now runtime by the interpreter. Now Java depends on what? Now tell me. Now you have to decide it. Yes, Java. Is it interpreter based or compiler based or both here? 3 options. Interpreter based, compiler based or both. What is Java here? Java depends on both. Java. See, Java depends on both. Java depends on both. Java depends on both. Both the compiler as well as interpreter. That's it. As well as interpreter. Right? Java depends on both the compiler as well as interpreter. Okay. 1 second. Same topic explain document also. See, you need not write in running notes. Running notes is not necessary. Okay. Very clearly prepared in documents. Okay. Very clearly. Yes, easy. Yes, very easy. Yes, need not to write running notes. Okay, just try to understand the classes. Just try to understand classes. Just you focus on the class here. Okay, running notes is not necessary. Suppose if I'm giving notes and you writing notes, time taken, wasting of time. No, I don't want waste my time here and your time also. Okay, 75 days, completely explanation programming. Yes, more than 300 programs we are going to discuss. 300 programs, how I can explain in 75 days? So only explains, no notes. Yes, everything prepared. All 300 programs prepared in the document. First 3 weeks logical building. 70 programs explain logic building. That 70 programs already prepared in documents. Every program is in document here. Okay. See, since yesterday you observing any point missing in document. See that. What are topics explaining here? Yes, everything is a document here. Yes, everything, every point I have prepared in document. Nothing missing in document here. Every point prepared in the document here. Okay, every point prepared. See, interpreter compiler, today topic, interpreter compiler. See, yes, that 9 differences. Same, even orders will not change. Okay, yeah, this is my experience completely. Document prepared. Suppose, just observe it. Suppose document copied from Google or some websites. Yes, class topics and document will not matching. Will not match. Never matching. Trainer way of explanation document both will not match. So both not matching means yes, he has copied from somewhere else. Yes, copied from yes some sites here and simply PDF generating and giving rates. But my class are like this. Whatever things I'm explaining, same thing will be in document. Even order also, points wise, even single line also, order will not miss. Same. This is completely my explanation. Okay. See that 9 points very clearly prepared. Okay, next. See about Java. Java depends on both interpreter as well as compiler. Compiler as well as interpreter here. Yes, in Java, errors checking with the compiler. Yes, if no errors, Java compiler generates dot class file. Okay, dot class file is a bytecode file. Okay, so Java runtime by the interpreter. Java runtime by the interpreter. See that? Yeah, this is see source code, but the source code converting into bytecode file. That bytecode file given to interpreter converting into binary code, right? See, source code to bytecode, source code to bytecode, source code to bytecode, bytecode to binary code, then process finally generating output here. Okay, see here, source code to bytecode by the compiler, bytecode to binary code by the interpreter. So Java depending on both the compiler as well as interpreter. Okay, Java runtime is interpreter based. Java runtime is interpreter based. Okay, yes. Now here's some question here. Yes, see, just simple, very small example explain here. Java C compiled. So what result? Dot class file, right? Dot class file. Java test running, right? Yes. Did you observe any exe file in this? In this process, compilation then running here. In this, yes, have you observed any exe file? Yes, dot exe file. Have you observed anyone observed exe file? Yes, dot Java file is a dot class, no dot exe file, no dot exe file. Yes, in Java, no exe file concept. Okay, see, Java is, yes, Java runtime is interpreter based language. See, these points, yes, 8 points. 8 interpreter based language don't have exe file concept. Interpreter based language don't have exe file concept. See, any language, runtime, any language, runtime is an interpreter based, is an interpreter based, is an interpreter based. Okay, is an interpreter, yes, interpreter based. One second. Interpreter based, don't have exe file, don't have exe, don't have exe file. Okay, so any language runtime is an interpreter based, don't have exe file. No, same point. Let us see with Java here. Java language runtime is an interpreter based. Java language runtime is interpreter based. Right? No question. See, as per this point, try to understand this point here. Any language runtime is an interpreter based don't have exe file. This 8 points. This 8 points. Interpreter based language don't have exe file. Okay. Not Java. Java language runtime is an interpreter based. No question is yes. Interview question. This is interview question. Yes. Can we create exe file in Java? This is a question. Or yes. Is there an exe file concept in Java? Is there? Yes. Is there? Is there any exe file? Exe file concept in Java. Exe file concept in Java. Yes. What is answer for this? Can we create exe file in Java? What's your answer here? Yes. Is there any exe file? Yes. Maybe these are that question asking here. Can we create exe file in Java? Is there any exe file concept in Java? No. Yes. No exe file concept in Java. See, if exe file is there, it's a platform dependent, but Java is independent of platform. But Java is independent of platform. Java is independent of platform. Okay. If exe file concept is there, compulsory OS dependent. Yes. Platform dependent. Yes. The topic tomorrow we'll discuss. Yes. Java is an independent of platform. The topic tomorrow. Yes. Tomorrow very interesting topic, no doubt. Yes. How Java made us independent of platform. How Java made us independent of platform. Tomorrow we'll discuss. Tomorrow topic that's okay. Yeah. So that's all about this. Yes. So this is just introduction. Java introduction. So finally conclusion here. Yeah, Java depends on both the compiler as well as interpreter. Java depends on both the compiler as interpreter. This point is clear. Next, there is no exe file concept in Java. These 2 points very clear here. Yes, about Java. About Java here. Java compiler as well as interpreter. But Java depends on both the compiler as well as interpreter. Yes, next in Java there is no exe file concept. Okay. Yes, next about Java features. Tomorrow topic is independent of platform portability. The topic is very interesting topic tomorrow, no doubt. Okay. Yes, tomorrow very interesting topic. Okay. Yes. Difference between exe file dot class file. See this. So tomorrow topic independent of platform. So that time yes, we'll be explaining about exe file dot class file. So what is exact how exe file is working? How dot class file is working here? So how Java made us independent of platform? That topic we'll be discussing in tomorrow class. Okay. Yes, I hope everyone you understanding these classes very clearly. Okay. Yes. Right. I hope everyone you understand. I hope everyone you understand my classes very clearly. Okay. Yes, don't worry. I will go very slowly, every topic slowly and clearly explaining. Okay. Yes, I'll go in depth, no doubt. Very clearly in depth I'll go. Okay. Yes. Yeah, that's all for today. Yes, tomorrow also same link. No change in link. Tomorrow also same link. Right? Yeah. So thank you guys. Yes, see you tomorrow, guys. See you tomorrow. Same time, same link.